Welcome to qnawire.
To find the magnitude and direction of the electric field at point P, let's remember that the electric field is going to be equal to kq divided by r squared. So in this case, we can replace r squared with distance squared. Normally we take the absolute value of q, and the direction is going to be that of a positive point charge put it at point P. In this case, with the positive charges, we're going to experiment. Let's call this q1, let's call this q2, and let's call this q3. So the electric field due to 1 is going to be pointed outwards because positive would repel. Over here, it is going to be pointing outwards as well. So this would be E1, E2. The magnitude of E1 and the magnitude of E2 are going to be the same because they are both of the same distance, and this is going to be equal to kq over distance squared, which we are told to be equal to E0. And then we're going to have the magnitude coming for Q3, that is going to be this vector over here. This is going to be electric field 3. And the magnitude of the electric field 3 is going to be equal to, now the distance is going to be the distance of the hypotenuse. So the hypotenuse would be a square root of d squared plus d squared. So a square root of 2 times d. So it would be kq over a square root of 2 times d squared. So 1/2 of kq d squared, which is 1/2 of E0. Now, other information that we have is that since the distances over here on the triangle are going to be the same, this angle theta is going to be equal to 45 degrees. So we know that electric field 1 is equal to E0 on the positive I direction. Electric field 2 is equal to E0 on the positive y direction on the j unit vector. Thus, the third one, E3, is going to be equal to the x component of E3. Let me put it in black over here. E3 on the x direction is going to be, let's take any of the angles. In this case, it doesn't matter because sine and cosine of 45 degrees is going to be the same. But just to be accurate, this would be sine function because the x projection is the opposite cathode from this picture. So sine of 45 degrees times the magnitude of E3. And E3 on y would be equal to cosine of 45 degrees times the magnitude of 3. Remember that E3 is pointing on the negative direction, so we need to add that negative value on each of them. And the magnitude of E3, we said that was equal to 1/2 of E0. So, with this information, the vector corresponding to the electric field due to the particle 3 is going to be sine of 45 degrees, which is 1 over square root of 2 minus 1 over square root of 2 times the magnitude, that is 1/2 of E0 on the I direction, and minus the same thing on the y direction. 2 times the square root of 2 is 0 on j. So, due to the superposition, the total electric field is equal to E1 plus E2 plus E3. The total field would be E0 on I minus 1 over 2 times the square root of 2 E0 on I plus E0 on J minus 1 over 2 times the square root of 2 E0 on J. The final result would be, let me put it now in black, Et is going to be equal to E0 times 1 minus 1 over 2 square root of 2 on the I direction plus E0 times 1 minus 1 over 2 times the square root of 2 on the j direction. So this already gives us the magnitude and the direction of the vector, but just to have it as a numerical value, the magnitude of ET is going to be equal to E0 times 1 minus 1 over 2 square root of 2, all of this squared, plus the same quantity, E0 times 1 minus 1 over 2 square root of 2 squared, and taking the square root of all of this. Just doing some algebra, we're going to have a quantity squared plus the same quantity squared. We're going to take the square root, so the magnitude of ET is going to be equal to a square root of 2 times E0 times 1 minus 1 over 2 square root of 2, which gives us a magnitude of E0 times square root of 2 minus 1/2. Thus, you can leave it like that or plug in the numerical value 0.9142 times E0. Now, to know the direction, what we know is that both of the components are going to be the same. So the direction is going to be 45 degrees on the positive first quadrant. So 45 degrees, 0.9142 times E0. And this would be the magnitude of the total electric field. And this would be point P. How do we know that it is on the first quadrant? Well, you can calculate the value of these components. You're going to notice that both of them are going to be positive. So in our drawing, it would be over here. And just for reference, let's put the total field somewhere around here. It would be on this direction, okay, with the same 45-degree angle. So that would be all. Thank you very much and have a good one.